Alright, what's up guys? In this video, I'm going to pick up some multivariable calculus. We're going to be talking about scalar functions and how to find the three-dimensional gradient. So we're given this scalar function, phi of x comma y comma z is equal to 2x squared yz cubed plus xyz plus x squared plus y squared plus z squared. And they want us to find the three-dimensional gradient at the point 1 comma 1 comma 0, and they want us to find the magnitude of whatever we get our gradient at that point. All right, so let me just remind you of the gradient. So remember, for the three-dimensional gradient, that's just del phi. It's going to be the partial of phi with respect to xi plus the partial of phi with respect to yj plus the partial of phi with respect to zk. And then we'll plug in the point after that. So let's go ahead and get the partial derivatives. So partial of phi with respect to x. We'll go up here and take the partial. Looks like we'll get 4x yz cubed. And then we'll look like we'll get plus yz. And it looks like we'll get plus 2x. Okay, and okay, so for the partial of phi with respect to y, it looks like we'll get 2x squared z cubed, because we're treating z as a constant. Then this would be plus xz plus 2y. And we need our last partial derivative, this time with respect to z. And so in this case, we're going to get 6x squared y z squared plus xy plus 2z. Now we need the gradient at the point 1, 1, 0. So we'll get that. So all you have to do is stick in a 1 for x, a 1 for y, and a 0 for z. And it looks like we're going to get 2. Now we need the partial with respect to y at the point 1, 1, 0. Looks like we're going to get 2 there as well. And then we need the partial of phi with respect to z. And again, we got to sub in the point. Look like we're going to get 0 when we plug in that point. So we'll write down what the gradient at that point is at the end. That way I ain't got to rewrite everything. So we'll put the final answers together. Now let's go ahead and calculate the magnitude. Well, actually, we'll need to put them together because we got to do the magnitude. So actually, we do have to do them. So our gradient at that point is going to be 2i plus 2j. Now they want the magnitude of it. So that's the square root of the sum of the components squared. So that's going to be 2 squared plus 2 squared, which is the square root of 8, which we know we can do prime factorization and reduce it down to 2 times the square root of 2, which would be our magnitude. So our final answer our three-dimensional gradient at the point 1, 1, 0 is 2i plus 2j, and the magnitude of our gradient at that point is going to be equal to 2 times the square root of 2. And that's your answer. All right, pretty straightforward exercise. So let me know if you got any questions. But that's going to be it, and I'll see y'all next time.